Okay, in this teaching worksheet, we are going to explore the last shape for this topic. So the last shape that we are doing will be something called sphere. So you will think of a sphere as a circular ball, like a basketball. Okay, so everywhere is circular. So you just imagine like a basketball or soccer ball. So there is one feature that you need to know. So for this shape, right, the feature that define it will be the radius. But you will need to visualize that there will be radius everywhere. So there will be radius everywhere as long as it touch the edges. So that will be the radius. So from the center of the basketball, any edges that it touch, that will form the radius. So there's a lot of radius everywhere. So because of the radius that's everywhere, the more defined one will be here. So the two radius will make up the full width of the sphere. So same thing here, the two radius will actually form the full height. So if we are going to fit a sphere into a cylinder, so later on at the end you will see something like this. So the two radius actually kind of form the height of the cylinder. So that is where we do the combination question. So other than that, at this moment, right, the characteristic of a sphere is correct. It's defined by the radius. How big the radius will decide how big is the sphere. So hemisphere is just half of it, except that when you cut it into half, there will be a circular portion, and then there will also be a circular base. So that is the basic idea of how a sphere look like. And then, okay, let's introduce the formula. So for the formula of a sphere is 4/3 pi r cubed. So this may be something that you're not very used to, is something like 4/3 times pi. For the radius, right, because it's r cubed, that means you're going to multiply the radius 3 times. So of course, to put it simply, we will just do a cube. We will not need to multiply it 3 times in the working. So later on, I'll be showing. So do understand the idea of r cube means you'll be r times r times r. So it's not the same like what you have encountered like r squared. Okay, and then the surface area, in this case, because everything is circular, so the surface area is made up of the curved surface area. So the curved surface area is 4 pi r squared. So there's a difference. So r squared is just r times r. Okay, so whereas in the volume part is r times r times r. So when it comes to a hemisphere, which is half of a sphere. So when there's just a half of a sphere, you actually just directly divide the volume. You just directly divide the volume by 2. That's why instead of 4/3 pi r cubed, you are getting a 2/3 pi r cubed. So you just simply divide by 2. But for the total surface area, it's not just so direct. Because of the cutting, you introduce a flat base. This part is flat. So you have to imagine, I think it's easier to imagine if you have an orange, you cut the orange into half. So you will see a circular base. So this circular base is here. So there will be a flat circular base, and then there will be a curvy portion. So the curvy portion is just divided by 2. So this part is the curvy portion, the curved surface area. So when you add them up, you actually get a 3 pi r squared. But do take note, the 3 pi r squared is made out of curved surface area and a circular base. Sometimes you might not have a circular base. Sometimes you can have a hollow kind of hemisphere. So if it's a hollow kind of hemisphere, you only have the curved surface area, which is only 2 pi r squared. You will not have the curved surface area. So you got to take note of this, especially if you are dealing with combination question. That means you are dealing with question that has more than one shape. Okay, so with this, right, I'm going to show you the numerical value. Okay, so for the first question, it's actually quite easy. It's just that they never draw it for you. So if you try drawing, so try to, the radius will be in the middle and stretch out. So that will be a radius 5. So for the volume, it is 4 pi r cubed. So if you're not familiar yet, you might just write out the formula first. So the radius is 5. So I will punch my calculator. Okay, usually my habit is to punch without the pi. So I'll punch it without the pi. So that will be the most accurate volume. Or sometimes the question might ask you to leave in terms of pi. Or sometimes you might need the volume for this, you might need this volume for the next part of the question. So you might, if you need this volume for the next part of the question, use the most accurate one, which is the one that's in terms of pi. So otherwise, right, the next step, I'll punch out using my calculator pi. If the question is not stated, in O-level standard, you will use this or you use the calculator pi. So right now, I am using the calculator pi. So if I'm using the calculator pi, I will be getting this value, which I'll round it to 3SF. So again, my habit is to write the decimal. I would like to write the decimal before I round off to 3SF. So for the curved surface, for the surface area, we only have the curved part. So that is just 4 pi r squared. So again, I will put in my radius. I will punch without calculator. Then I will punch using calculator pi. And then I will give it as my 3SF answer. So in case the question asks you to leave it in terms of pi, which is possible. So in O-level, there are questions that ask you to leave it in terms of pi. So that will be the kind of answers that we say, leave it in terms of pi. I will suggest if this is not the final answer, you don't need to press out the 3SF. So that is to preserve the accuracy. So in the next example, it is the same idea, except that we are working backwards. So in the next example, we are working backwards based on the volume. So we do not know the radius, but I do know that the volume is 1000. So you set up the formula and then you try to do your algebra. But some of you may be confused because of the pi. So what you can do is you divide by this. So try punching out. You might not get a nice answer. Okay, so if you try punch out, you got this number. So you got to take a cube root. So on your calculator, you take a cube root of the answer, you will get 6.2035. So round off to 3SF. Yeah, that's the correct answer. So right now you use backwards. You are working backwards based on the volume formula because you are given the volume of the sphere. So in the next part, I'm given the curved surface area. So I got a brand new sphere. Okay, we cannot assume that they are the same sphere. So again, I do not know the radius, but I do know that the curved surface area, the total surface area is the 324 pi. So you should work backwards based on your surface area formula. So that should be 4 pi r square. Since there are pi on both sides, you can just drop the pi. It's as good as dividing by pi on both sides because pi is just a number. So slowly you divide by 4. And then you take a square root. So obviously, when you take square root, there will be two answers. So of course, radius being a positive value, you should have reject the negative answer. So this is how we work backwards. So it depends on whether you are given the volume or the surface area, then you work backwards accordingly.